Thank you very much. So, thank you very much for being here. It's Maven Puzzlers. It's actually one of my favorite sessions ever. And I hope you're ready for a very, very interactive session. This is one of the sessions where actually I expect you to take your phone out. My name is Ixchel Ruiz, and this is a little bit about the story of my life. I'm from Mexico. I live in Switzerland. I work for JFrog. I'm a Java champion. And actually, that doesn't look okay. Well, we skipped, well, it was my fault. Anyway, so I work in different open source foundations, and I contribute into two books. The last one was DevOps Tools for Java Developers. So I'm actually very into open source and Java, obviously. And this is Andres Almiray.
So I'm Andres. I'm also coming from Mexico, also living in Switzerland. So now it's appropriate for us to say, good see me tonight. Yeah, I know. That will make you laugh. And so we travel around the world talking about experiences that we have had across the years working in closed source environments and open source environments. And that's what we want to do. We want to share information. We want to share knowledge with you. And today we're going to share some information regarding the Maven build tool.
And why do we pick Maven? We had a very interesting conversation with Roberto here about talking about build tools. And the point here is that we like to talk about interesting and important tools in our industry. And one way to actually be more effective is by using predictable, reproducible, automatic tools that follow convention over configuration. So let's talk about tools and build tools. Why are we talking about Maven today? Because this is still the most popular tool out there for building applications. This is, for example, from the State of the Union in software artifacts from JFrog. So we're still in our customer repositories seeing a lot of Maven repositories being there. So it's one of the most used repositories if you're using Artifactory.
Okay, so raise your hand if you use Maven as your main build tool. See, most of you.
This is the Maven Puzzlers.
So, but even if you did not use Maven as your main build tool, you will still have to consume the Maven POM file, the POM XML. If you use Gradle, SVT, Leiningen, all the others, we use the POM XML file as the de facto standard for metadata, describing metadata for our dependencies.
So you're still publishing or consuming, you still have to deal with the POM XML. So it is important that you know how it works. And if we see at these different reports, Maven is really the most popular one. For example, this is from JetBrains, and it's also the most used one. So let's talk about Maven. And this is you start seeing like QR codes. Even though the slides are going to be available, if you follow the QR codes, you will find all the things that we're talking about. So why does this session came to be? Well, turns out that dependencies are not always the same. We don't use the same version number of a dependency. And sometimes we think that we're using a specific dependency, but in the dependency graph, things are not what we expect. And suddenly we are in the dependency resolution hell, and that is usually my reaction. Who here adores the exception class not found exception?
So class not found exception, that's quite a popular thing that happens to us. Have you ever encountered the one that says the missing method because, or actually I don't even recall the name of that exception because I hate it. When you expect a method to be available but it's not because the class version is different, right? Have you ever got the linkage error because a native library is not what it's supposed to be? And that just happens because we think that what we're building has the correct dependencies, but it doesn't.
Another question that I want to ask you, like for example, you have done a Git clone. You have just joined a new team. You have a fresh environment. You do Git clone. And if it's a Maven project, what command do you execute?
I hope it's not Maven clean install.
If I let him talk, we will only spend this hour talking about the rants about why shouldn't you use clean install and why should you use verify.
So who knows about the verify lifecycle phase? See?
Okay.
Just
There's some hands
30% or so.
up,
Yeah.
but
So as you know, Maven is as a build tool executes what is known a lifecycle set of phases, and it does it in a sequence from one end to the other. Now, most people, when they do clean, they invoke the lowest lifecycle phase that we see here. I mean, the sequence. Oh no, it's the one in the middle. Just simply deletes whatever you have compiled or any artifacts that have been created. But in the case of the main sequence, the main lifecycle, we go through validate and compile and test package. You know this. Then notice all the way to the top before
here,
install.
top.
Right? Before install, there is verify. The whole point of install is to take all the artifacts that were built or are attached to the current reactor or compilation session and copy them into another place in your file system. This is known as Maven local. That's the only thing that install does. But because verify comes before, everything that verify does will be invoked when you do install. Verify is there just to be sure that you can compile and test and package and run integration test cases and everything else just before you're ready to publish to Maven local. But if you don't have to publish those artifacts, if the only thing that you want to do is just check that the project is building, check that the integration tests are fine, then verify will do the
It's
work
more than enough.
most of the time.
It's more than enough, and usually it will do whatever you want. There are small corner cases where clean install may be required, but most of the time, verify is enough.
Right. So my recommendation is use verify most of the times, and if something is not working correctly, you're switching within branches, then you probably need a clean. Or if there is a plugin that is not working correctly and it forces you to either use clean or install, then that plugin is faulty. And that's one thing that we as members of the Maven community, we need to be aware of so we can fix that plugin.
So let us know. Well, let them know. And I have a slide for that. Well, the reason we're here, and actually why this is a compelling session for a lot of attendees, is because sometimes we don't understand the inner rules of one of the most used tools. And the thing is that we have most of the time this case. We have the same, almost the same dependency, but with different versions. And we actually not very sure which one is going to be resolved at the end of the day.
So now comes the interactive part of the session. We're going to ask you to take out your phone and not Twitter, but that one.
No Twitter.
So take out your phone and scan this QR code, and we're going to run a series of questions. The first is going to be 4 warm-up questions, and then we get into the actual quiz. It will be 14 questions in total, separated in 3 different sections.
Yeah.
And that all these questions have happened in production. They are for real.
Really?
We're not just joking around with what the potential hypotheticals. No, this has happened for true.
Yes. So remember 14 questions, and we will test our knowledge
and
on
if
Maven.
for some reason you cannot scan the QR code, just go to menti.com and then the code on the top, the number will also give you.
Yes, or the QR code over there. So the first trial question: how do you install Maven?
Let's see.
Okay, for the people that are using SDK Man, thank you very much. Thank you very much. For the ones that are not using it, even though they are not using it, this is my moment to pitch it. So why do I love SDK Man? Apart from actually managing the different versions of Maven, it also can help you manage your versions of Java. And one of the features, the killer feature for me, was able to run different versions of Java in different terminal windows. No, without any changing any link, without changing any variable, nothing.
Right, because for the 27 of you that have answered that you are installing Maven manually,
29.
Well, you have to locate the zip file or the distribution somewhere, download it, unpack it, place it in the directory that you want, and configure environmental variables, Windows, Linux, Mac, and off you go. And the next version that comes in, you have to do the same thing over again and over again. The whole reason why we have package managers is to automate all these steps. Now, it doesn't matter really which package manager you choose, just automate what you can do manually. But if you were to choose SDK man, then you get additional benefits. All right.
Well, it does matter. We disagree on this one.
Okay, next question. Which version of Maven are you currently using? And
Okay.
So
That's
good.
wow. That's a great.
Oh, someone is using 4. Good.
Yes.
Okay, that's a good thing. And wow. Okay, so almost half people that are using 3.9.2 is the latest, most modern version of Maven that is still somehow compatible. I say somehow because there's a set of APIs that have been changed, and some plugins have been reported to be broken with 3.9, and this is expected. If you want to be conservative, then you should go with 3.8.8. And if you're using 3.6.3 or older, why? I don't understand. There are some companies that move slow. There are reasons why they cannot upgrade their tools, but if you can, please try to do as soon as possible. Try to upgrade, because there have been security issues that have been fixed, vulnerabilities, performance improvements. So at the very least, move to Maven 3.8.8, if not to 3.9.2. And for those that have already tested 4.0.0 alpha, thank you so much. There will be a bit more breakages, and this is expected because a major jump in the version number. But what we're trying to gather is that information, that feedback, to make sure that we don't break that many things. And if we do it for the right reasons.
So the whole purpose here is, well, one of the ideas that we want to bring to you is to start using it right now. It will break. But if you have created something, or you are depending on a specific plugin, this is the moment to provide feedback to the Maven team. So when you need to upgrade, it's going to be painless, or at least more painless.
Yes, that's great. Okay, next question.
Do you use the wrapper? And the first question would be, what is the wrapper?
And the person that should be here is not here. Because, very quickly, so who uses the wrapper? Almost half and half. For those that do not use it, do you know what a Maven wrapper is? If you do not know, it's a script that allows you to bootstrap a specific version of Maven, and you attach that as a script to your project. So you can provision or download a specific version of Maven when you want to run your build.
And it's not only that, because once you pin out a specific version, you know that you can expect certain behavior, because things can change. For example, all the versions of the different Maven plugins.
Yeah, we will have to talk about what the Maven Super POM is, which will eventually come into play in the following questions. But just running the story short, the Maven wrapper is an idea that came from the Gradle ecosystem, so it was ported to Maven. And the original author of the Maven wrapper is right here at this conference, at least not here in the room. His name is Brian Demies. He's currently working at Gradle. So if you go to the Gradle booth, you're going to meet him. And the whole point of the Maven wrapper is that if you don't have a suitable version of Maven to run your project, then this thing will be able to provision it for you.
So for CI/CD environments, it's perfect, because you don't need the agent to have that specific version installed. It will actually be downloaded even from an internal server, because you can actually configure the URL. So if you want to prepare your own Maven distribution for whatever reason, it's going to be easy to consume. The other one is, do you use the Maven daemon? But again, what is the Maven daemon? And why would it be useful to use it?
Yeah, this is kind of like what expected. Not that many people use it. So the Maven daemon is yet another idea that came from the Gradle ecosystem that now Maven uses. Every time that you run a Java project or a Java process, this is what happens. You bootstrap a JVM that takes some time, then run the process, and once you're done, that VM just gets discarded. And the next time you want to run the process, you bootstrap that VM once again, pay the whole price, run, and then go. What happens with a daemon like this is that you pay the price for starting the VM the first time, right? You run the process, and before it finishes, this JVM, which is already warm, it's already been activated, moves into a background process. So that next time you run your original application, there is no VM that needs to be warmed up or bootstrapped. It just uses the one in the back. So boom, it's much faster. So you use the Maven daemon to have faster builds.
Okay, so those were the warm-up questions, and we will start with the real question. So are you ready? When we said that this works, or the right answer is because we're running Maven dependency tree. So
that will be the command to determine if, when we say, does this dependency resolve to X or Y, is because you have run this, and then the answer appears.
So let's start. This is our first POM file. And as you can see, it's very simple. So in the dependency block, I have two dependencies. It's going to be WAVA 27 and WAVA 28. So all the questions are going to be about like what version of Java are we going to have at the end of the day.
We're not just picking on Guava because Guava is there and some people don't like it, like myself. It's just because Guava is so everywhere. You're just gonna find it. And the problems we may find is they are not unique to Guava. They are general in the sense that it can happen for all kind of dependencies.
Okay, for the 20 plus people that says build error, I'm with you. I'm with you. This is the thing that I actually expected, because I'm saying I want the two versions at the same time. So Ixchel, tool, make up your mind. How can you ask for two different things at the same time?
Okay, so I'm happy to say that the 28 of you that chose build error will be correct if you were using Maven 4. Now, I know for a fact that only 2 of you selected Maven 4. So, and that doesn't match to 28. Now, this is a warning in Maven 3 and will continue to work. And the chosen version will be version 28.
So why?
But wait a second. And in Maven 4, this turns out to
be an error.
Proper error. So this is the reason why we encourage you to test out Maven 4 already. Now, for those of you that chose version 28, is it because 28 is greater than 27? So we're following semantic versioning? Let's see some hands.
Okay, there were like 5 or 7 hands saying yes.
If it's 28 because it's the last one defined in the file.
So okay, more hands. So yes, thank you very much. You know the answer.
So if we were to switch things around and define version 28 first and 27 second, will 27 be the selected version?
Yes.
Everybody that said before, yeah, it should be because it's the last one. It doesn't matter the number.
It is the last one. So the last one wins.
When we have a direct dependency like this one, the last one that is defined wins, no matter the number. Remember that.
As interesting as that is, so it was not the newest one. It was the position. And what happened is somebody changed or sorts out the entrance or the entries in your POM XML.
There are at least 2 plugins that allow you to sort a POM file given certain conventions, and they can sort the dependencies definition. So if someone changes that, suddenly your build might no longer work as you expect.
Because the last position, the last entry is going to change. So how do we bring sanity into this? At least the sanity, if you're using Maven 3, the sanity of saying Ixchel asking 2 things that are completely different, well, not completely different, but you have to make up your mind, is with this.
So who knows the Maven Enforcer plugin?
Not many hands.
Not that many of you. Okay, so if you only take one thing away from this session, is please configure the Enforcer plugin, because I guarantee you, I mean, as long as you configure at least one rule, this is going to break your build.
Yes.
And you want this.
Yes.
Because your builds are already broken and we don't know why. And this plugin and these rules will bring up those issues to the surface so that we can see them and then find a ways to correct them.
So, it's going to be surprising. I guarantee you, you will be surprised. but it's going to be at some point a good surprise.
Right. So in the case, in order to turn this warning into a real error, you configure the enforcer plugin and add that rule: ban duplicate POM dependency versions. Boom, you're done.
Yes, and then in Maven 3, you will actually have a meaningful error telling you.
And I think in Maven 4 will immediately tell you, no, this is wrong. And depending on the timing that you run the enforcer plugin can also tell you, yeah, this is definitely wrong.
So it's going to tell you, like, you have a duplicate dependency declaration in this project, so make up your mind, bring sanity into your project. Okay, so let's continue with the questions and let's try to be faster.
Okay, so question number 2.
Okay, now, this is an easy one. So in the dependency block, I'm adding WAVA 28 and I'm adding a second dependency. The last dependency is going to be Google Truth version 113, but Google Truth brings actually one particular dependency, which is going to be WAVA 30 version Android.
Well, not transitive dependency.
It's as a transitive dependency, yes. So which one is going to be?
So are we going to get 30.11 Android? Are we going to get 20 JRE? Are we going to get a build error?
Okay. Perfect.
Nice. 80
build error. No.
No. This actually works.
This works.
And
as expected.
Regardless of the Maven version. And 84 of you are correct. 28 will win because
direct dependencies always win. Here it doesn't matter the position. A direct dependency will always win. So the right answer was 28, and I'm happy everybody got it right. So one of the things that I really like, it's semantic versioning. I use semantic versioning in my projects, and if you haven't used it before, or you're, we actually encourage you to follow semantic versioning.
But as it turns out, Maven itself, from the core, has no clue about semantic versioning. We asked this question to Robert Schulte. He was the Maven PMC chair at the time, and he told us, well, Maven never looks at the version number. It only cares about the position. And by the way, I just mentioned Maven PMC chair. We have the Maven PMC chair at this conference. Karl-Heinz Marweis is in attendance. And so anyway, the point is that if you're expecting Maven to handle versions and semantic versioning out of the box, it doesn't do it.
It actually doesn't follow anything between the version tag. So nothing. But if you want to bring something similar,
if you want to instruct Maven to work in that regard, if we say dependency conversions, when we activate this rule, at least what Maven will do is detect that you have two different versions of the same dependency within your graph and let you know, hey, this might be a problem. Fix it.
So, for example, as when you configure this particular rule in your POM XML and you activate it, in this particular project, very trivial project, it already detected two different versions around the dependency graph that may be in conflict. And even, this is really interesting because it will tell you, it will make it explicit, the idea that you're bringing possibly two versions of the same dependency in some way. So at least it's going to tell you you may have a problem.
But this is not semantic versioning. There is yet another rule, which is called require open bound depths. Honestly, I will have put this as apply semantic versioning, but they chose that name. But this is the one that will tell Maven, you have at least two different versions, and one of them is higher than the other following semantic versioning rules. So you might want to select the greater, or make sure that the lower is the one selected, so you will have to change your POM XML with following certain rules. The whole point is that the enforcer can give you these capabilities that Maven doesn't have or doesn't offer from core.
Okay, next question, and I hope you are connected. If not, I'm going to show it right there. So the next question, we have again a very simple POM file. We have in the dependency management block.
Who knows what the dependency management block is? Okay, half of you.
In the dependency management block, we have version 27. In the dependency block, we have Google Truth that we know it's bringing version 30. So which one is the one that's going to be resolved?
All right, let's see some answers. Ah, curious.
Okay, for the half that he actually knew that what the dependency management block is, makes sense. So I will attribute that to the 27.
There's no real error. This works. So about 60% of you are correct, because this is how the dependency management block, you have not seen it. It's like a lookup table. For every group ID and artifact ID, Maven will save that information. Oh, you want to use version 27 of Guava, so I will remember that. And then comes and parses the graph. And anywhere where it finds a matching group ID, artifact ID, in this case Guava, and there is no explicit version defined, which is the case of a transitive dependency, then the specified version 27 is going to be chosen. So again, anywhere in the graph, and as many times as a non-explicit version is there, you're going to use the one in dependency management block.
So it works like a catalog. Andres likes to call it like a lookup table, but for me, it's more like a catalog. If there is no really clear decision, clear meaning a direct dependency, then this is the one that is going to be used as reference for every dependency that it's bringing it. Okay, next question. So this one, we are now introducing something interesting. We have two dependencies. We have our dependency management block saying 27. We're saying in the dependency block, we're bringing Guava 28 and Google Truth 113.
So we just added a direct dependency to the previous example.
So who is going to win?
Is it going to be the version from the dependency management? Is it going to be the direct one? Is it going to be the transitive? Please don't answer bill error.
Too late. Too late.
No, there's no bill error yet.
Yeah, no. Yeah, true. Okay, somebody just made it.
I had to say it. Well, turns out that the chosen version will be 28.
Why? The reason is very clear, and we have said it before. It doesn't matter what you have, a direct dependency always wins. So that rule
continues to work. Okay, next one.
So now we're going to make things a little bit more interesting. We're going to bring two dependencies that as a transient dependency at the same level bring Guava. And one is Android and the other one is going to be JRE.
So these two dependencies of Guava are the same distance from the consumer, or the POM that is declaring the direct dependencies. If any of these dependencies were at a different position, then one of those will win over. But right now, the whole point is that the two of them are the same distance. So this is a key.
Because the one that is closer is going to be the one that wins. So now let's see this POM file. I have in the dependency block two dependencies. Use 510 that it's bringing 30 JRE, and the other one is Google Truth that it's bringing Android, 30 Android. So who is going to win? Remember, like Google Truth, that is the last one to be included.
Do
it's
we
bringing.
Have any trolls in the room because they're selecting bill error?
No. But as I said, remember we in Google Truth is bringing the Android 30.1 Android, and the other one Use, which is in the first position, is bringing the one without Android.
Right. So I'm happy to say that 59 of you were incorrect, because the version that wins is the one that is coming from Use. Remember, both of them are at the same distance. Now, here's the catch: when transitive dependencies are found in the graph within the same distance, the first one that is found is the chosen one.
First one. So position does matter. We learned that really early. But in this case, it's the opposite.
If we were to invert the definition of dependencies and put truth first and Use second, Then 31.1 Android will be the chosen version of Guava. Again, it works because the first one that is closest that was found in transitive. But if it's a direct one, it's the last one that is defined in the file.
Okay. But I want you to keep that rule in mind. Direct, last, transitive, first. Yeah, we have a question.
I cannot say why the decision made. I think it's a historical reason why there's a difference when directs versus transitives. That's a fine question that we can ask Karl-Heinz.
Oh no, don't ask that one. I mean, we're not here to try to know the whys. I mean, in our industry, I love every single time that I join a new team and I ask something that it's like, and there's always somebody that says there is an historical reason for that.
There's a question, comment? Yes, so we don't, right now we don't have a clear answer why the two rules work like this way. It's just that they work.
My question was, I don't really want my dependency tree to depend on the order. Are there some enforcer settings? Okay, yeah.
There are enforcer rules that you can use in order to detect this.
And
Yes, some of those we already mentioned, and there are others that you can use to make sure that the resolution of the dependency graph turns out to be deterministic.
Yes. Okay, then I didn't even need to ask this question, but I'm happy to see that the concept of the dependency management block is now very, very well understood.
Because the only thing that we added is a dependency management block.
And we change.
That we switch the dependency order, right? Truth first, Jew second. And no matter the order, the version defined by the dependency management block is the one that wins.
So, when you have this case, define it in your dependency management. Define all the things that actually matter for you, like should be everything, but anyway, and declare it.
Right. So this is the end of the first section. We go into the second section because it's easy to reason about dependency management when we have just one POM file. What happens when you add 2 or 3 or more?
4. Multi-project builds. Let's start with the easy idea. So we're going to have our parent POM and our child. Yes, and our child. This is my parent, and this is my child. Or consumer, producer, well, no, consumer. So it's very easy. In the parent, I have a dependency block that says 28. On the child or the consumer, I have, well, first of all, I imported it. That's nice.
Define the parent, yeah.
Well, not imported it. I defined the parent. And then I'm going to declare the dependency of truth. And truth, we know that brings 30.1 Android. So which one is going to be selected?
Where's the
Yeah, it's just sorry.
the graph?
And actually, I already gave the answer.
Yeah, well, you already know. So the version will be resolved will be the version coming from the parent, because this is what happens. When Maven reads the, we're going to resolve dependencies starting from the child POM, right? This is the one that we care about. So it reads the child POM and sees that it has a parent definition. So it reads that definition, the coordinates, locates the parent, and parses that parent, right? So now when it parses the parent, it finds that has some Maven coordinates and that a dependency definition, so it makes sense of that. But it notices that it doesn't have explicit parent, but yet every single POM file has to have a parent. And if it's not explicit, that's going to be the Maven super POM, which is tied to the version of Maven that you're running. So if you're running Maven 363, it's a version of that super POM. And if it's Maven 392, it will be a different version. And within these different versions, there may be different configurations. So one uses a version of the clean plugin and another uses a different version of the clean plugin. End result is, if you move within Maven versions and you do not fix every single plugin version that you're consuming, just by upgrading or downgrading Maven versions, your build will no longer be reproducible and it might give you different results. So in order to make this work, you can use the Maven wrapper to say, I want to use this version of Maven, which ties it to a specific version of the super POM. And you can also define every single plugin version that you're going to use. Now, so once Maven reads the Maven super POM, it says it has some configuration, grabs everything that is needed, goes back into the parent. The parent says, I have a dependency, it's direct one, perfect, and puts that into what is known as the effective POM. So it's kind of like putting everything in one mega POM, right? And then comes into the child and says, oh, you have another dependency definition, it's transitive, so I put it in the effective. In the end, we have an effective POM that has one direct dependency and one transitive dependency. We have seen this use case before in the previous question, so the answer should be
the direct dependency.
Wins.
So the direct dependency always wins. It doesn't matter the position. Now, we have added something different. In this case, to the parent POM, we are adding in the dependency management block version 26. Nothing happened in the consumer or in the child. So what is going to happen? So we have dependency management block on the parent 26, the direct dependency 28, and a transitive dependency on the child.
Right. So let's see. So for sure, the transitive dependency should not be the chosen one. Good.
And I already told them because I have been saying this over and over. So pay me attention. Direct dependencies always win.
If you look again into the resolution of the child parent super POM, we end up with a direct dependency, transitive dependency, and a dependency management block. But we know that direct dependency continues to win. That's why 28 is the chosen version.
Okay, now we change it a little bit. We simplify a little, and we say in the parent POM, I put a dependency management block with 26, and a transient Google Truth in the parent, in the child, with version. This one is going to bring Android.
Oh, build error. Interesting. No, this actually works. Okay, now go back, and 10% of you're not correct. Sadly, no. Because we have the dependency management block. We don't have an explicit version in the child of Guava, so that means whatever we put into the dependency management block, if there is a match, should give us the version, and that's what we have. So we end up with version 26.
So dependency management block will win over transitive dependencies if there is no one direct dependency. We have seen that direct dependencies win all the time.
Okay, so last question on this section.
So in this case, we again, parent dependency management block 26, child dependency management block version 28, and then a transitive dependency that is bringing Android.
All right, so let's see. Which version is going to win now? The parent said 26, right? And the child has 28 on dependency management. Okay, good.
So we know it's not going to be the version number because Maven doesn't understand version numbers.
There's no big error. This actually works.
The other question that you could have is maybe the position. Like maybe 26 is going to be imported or resolved in the super POM in a different position, because we know the transit is not going to win. We know that too.
Yeah, 28 is selected again, not because it's greater than 26, because Maven doesn't know about semantic versioning. It's just because when you follow the rules within the child, the parent, and the super POM, when it comes back, it finds the dependency management block of the parent first that says version 26. Okay, puts it in the effective POM. Then goes into the child, parses that, and finds version 28 in its dependency management block. They have the same coordinates, same group ID, artifact ID. So the child overrides whatever the parent said. That is why version 28 is the winner.
Kids are always right. Okay, now we're going to enter the last section. And this is going to be about bombs, not the S-bomb that I like to talk about, the software bill of materials, but we're going to talk about a different thing. So here, who uses, for example, Quarkus? Okay, or Spring Boot? Okay, go out.
Helidon?
No. Okay, Helidon, we have to. Okay.
Jackson? That counts. Jackson? JUnit?
No, JUnit, honestly, everybody should have raised their hands.
Okay, so do you know what a BOM is? BOM stands for a bill of materials. Basically, it's what we have on that side is a POM that contains a dependency management block, and within that block you can have as many dependencies as you want. There's no official name, but I like to call these things. There's a clear distinction whether you have a BOM that provides all projects related to itself, so that will be JUnit. Everything is JUnit X, blah, blah, blah. And there's everything that is Jackson BOM is Jackson Core and Jackson Databine, blah, 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 but there's only Jackson. Whereas in the case of Quarkus and Spring Boot and Micronaut on the others, you will have those dependencies, JUnit and Jackson and Micronaut and whatever, everything else. So that is known as a stack BOM, whereas this will be a library BOM. Regardless of if you use one or the other, you consume them in the same way, which is define inside the dependency management block a dependency for that, but you have to add 2 additional XML elements, the import scope and the type. If you do not define type POM, Maven will think that there is a jar file associated with this dependency. I will try to find it, but there is no such thing as a jar associated with a BOM. You see the packaging over there is POM. There are no binaries. All right, the most important thing about a BOM file is the dependency management block.
So, again, here I have my BOM. Here I am importing it or defining it. And here I'm introducing the transient, well, the 2 dependencies that will bring WAVA in a transient version. So the versions are going to be 30 Android when I have Truth and 30 JRR when I add Juice. So which one is going to be used? Okay, no build error. I will remove that one.
No, it's fine, it's fine, it's okay. There's no build error. And the chosen version will be, drum roll, 28.
Why?
Because we are importing the dependency management block from the BOM into our consumer. It is as if that block here was written in my effective POM, and we know that that plus the transitive dependency that we find before, we've seen this use case before, the version that we define that matches in dependency management block is going to win. And this is what we want. We want to encourage reuse. That's why we have BOM files.
Okay, next question. This is very similar, but I added into the BOM the dependency WAVA in the dependency block, WAVA version 28. So I have dependency management in the BOM 26. I have a direct dependency 28 on the BOM, and I have in the consumer a dependency management block. Well, I define it there. But in the dependency block, I have Google Truth that brings which version? 30 Android.
Yeah.
So I can have 26, 28, or 30.
All right. Awesome. 58% of you were wrong. I know that we've been saying direct dependencies win over no matter what. Yes,
what happened?
Yes, that is true. But also remember that when we say that in BOM files, the most important section is the dependency management block. And we only import the dependency management block from a BOM. Any other XML element, like
dependency, this is totally ignored. This
they
doesn't
do not exist from the point of view of a consumer.
So when you're dealing with BOMs, only the dependency management block works.
Yep.
The rest is ignored. Okay, next question. And in this case, we actually added the dependency management on the BOM. That's perfect. Now we have on the dependency management on the consumer, we have version 26. And we have one that brings it as a transitive.
Yeah, right. So we have an explicit version here and we have an explicit version over there.
So now the question is 28, 26, or 30?
No build errors, please.
Sorry. Okay, so which one is going to be? Here it
That
looks
and
like
that.
the bomb is going to introduce 28, but I'm saying 26 because the transitive we know that it's going to lose. So that we know.
Yeah, but we expect it to lose. So it turns out that most of you were correct because it's an explicit version, but it's everything that is I'm going to say like double explicit. That doesn't make any sense. The explicit versions will always win over everything else. So we are importing something that also has an explicit version, right? But this explicit version on my consumer is closer, is nearest to me, the consumer, than everything else that I'm importing. This is the reason why 26 wins over what I'm importing, which is 28.
And it doesn't matter about the position. Here
Yeah, I could put 26 earlier or later in this case, and 26 will still win.
so that's okay. At least that's sane.
Okay, last question, and we're done.
So in this question, in the dependency management, we have 26. In the dependency, in the consumer, in the dependency block, I have 28. And truth that is bringing 30 Android. So which one is the one that is going to win?
Definitely, you guys are trolling me.
26
There's 4% air bill
from
error.
the bomb, 28 as a direct dependency in the consumer, or the transient one. We know that the transient one, no.
So 78% of you are correct. Why? Because direct explicit dependency wins over every single time.
Okay, this is the QR code for the GitHub repository where you can find all these questions, all this code, and the slides, and that is also going to be available. So we want to encourage you to use semantic versioning for sure. Please use the Maven Enforcer plugin. Really is going to make your life easier after some pain.
Break your builds earlier than rather than later.
Fail fast, fail often. Okay, no, but eventually it will be a path to calmer waters. And as we said, today here we have Karl Heinz, so he is grateful for any feedback or question.
And that's, by the way, that's Brian. That's the author of the Maven wrapper.
And so this is a great chance to talk about Maven in this conference. If you have any more questions, please let us know. And we are always looking for ideas into what to add as questions for the next edition.
All right. Well, thank you for your time. I hope that you have enjoyed JCon so far. We still have a few more sessions to go. So again, one more time, thank you for being here.